There's a YouTube documentary called The Thinking Game about Google DeepMind and AlphaFold in particular. AlphaFold is a technology that folded all of the proteins on Earth, so you can work out uses of proteins for pharmaceuticals, medical purposes, etc. I'll read the whole article. A guy in Australia has used AI and ChatGPT to create a cancer vaccine for his dog, and it worked. He spent some money on this, and he had to go through a lot of red tape, but he's built a vaccine which has reduced his dog's cancer by half. He did it using ChatGPT and the protein folding data from AlphaFold, from DeepMind AlphaFold project. Very cool. Now, this is a toy example. So I've seen a lot of people say, why do you do all of this? Why did he spend thousands of dollars trying to save a dog? And he just saved his dog. What's the big deal here? You need to look beyond this, beyond the specific story, to realize what the larger implications of this are. So this guy had a dog called Rosie, a funny looking mutt dog, I'm sure very cute, only had months to live until this guy, Paul Corningham, got to work, had Rosie's DNA synthesized, or got the genome for $3,000, the exact genome, fed it into AlphaFold, fed it into ChatGPT, and worked out how to synthesize a cancer vaccine, a tailored vaccine for his dog's Rosie's cancer, and it worked. And they reduced the cancer by half using this hyper-tailored vaccination. Now, obviously, this is just for his dog. This is just one person. The implications of this, though, are personalized medicine. The ability to create drugs, to create pharmaceuticals, to create vaccines for cancer, apparently, that are tailored to a specific individual. Because a lot of the problem when we give medicines and pharmaceuticals to people is because it's a broad range drug. So it's going to come with side effects. It's going to mean it's less applicable to that particular person. What he's just shown us is you can use AI and you can go ahead and create personalized, tailored medicine. Really cool. This guy's not medical. He is not a medical practitioner, but he went ahead and used these tools. So Mr. Corningham threw thousands of dollars at veterinary chemotherapy and surgery, which slowed but failed to shrink the tumors. Now, after treatments with a custom mRNA, a nucleic acid cancer vaccine over the Christmas break, the tennis ball-sized tumor on Rosie's hock has shrunk in half in a recovery that has astounded researchers at the cutting edge of human cancer treatments. I was like, holy crap, it worked, says Martin Smith, an associate professor of computational biology and director of the Ramaciotti Centre of Genomics at the University of New South Wales. It raises a question: if we can do this for a dog, why aren't we rolling this out to humans, to all humans with cancer? It gives hope to a lot of people. So what I love about this story is it's just a guy who thought, I'll give it a shot. So he is a non-medical professional. He threw the information into ChatGPT. He got this genomic sequence for $3,000. I went to ChatGPT and came up with a plan on how to do this. He said the first step was to reach out to the university to get Rosie's DNA sequenced. So you take healthy DNA out of her blood, and you take the DNA out of her tumor, and you sequence both of them to see where the mutations have occurred. So you can see the difference. It's like having the original engine of your car and a version of the engine 300,000 kilometers down the road. You can compare them and see where there's damage. This is hyper-tailored to this particular dog. But extrapolate out, we can do this with humans. Once the University of New South Wales produced the DNA sequence, Mr. Corningham ran it through different data pipelines to find those mutations, and then I used other algorithms to find drugs to treat the cancer. Again, he is not a medic, he is not a pharmaceutical researcher, but he used AI tools at his disposal to get this done. Paul was relentless, Professor Smith again. He called and told me he had analyzed the data and found mutations of interest, and then used AlphaFold, an AI program. He used AlphaFold to find the proteins that were mutated and then identified potential targets and matched them to drugs. And he was wondering, could I help him find someone to synthesize this compound that he'd identified? The interesting thing here is that it took more time to get the green light, to cut through the red tape, to synthesize and administer this vaccine. That took several months than it did for an amateur, a non-pharmaceutical researcher, to come up with the idea for the vaccine. It took more time to get the go-ahead to use this stuff. This is the first time a personalized cancer vaccine has been designed for a dog, Professor Thorardson said. This is still at the frontier of where cancer immunotherapeutics are, and ultimately if we're going to use this for helping humans. What Rosie, the dog, is teaching us is that personalized medicine can be very effective and done in a time-sensitive manner with mRNA technology. Very cool. I'm going to put this whole article, I'll remove the paywall as well so that more people can get access to it, into the newsletter. Basically, the technology is well ahead of the ethics of this. So Mr. Cornyn, he still needed ethics approval to use it. Even though the vaccine was ready, he was not allowed to use it on his dog. I had to do everything by the book because you can't just create a vaccine in Australia, he said. The red tape was actually harder than the vaccine creation. I was trying to get the Australian ethics approval to run a drug trial on Rosie. So he needed to get a full drug trial approval to run on one dog. It took me 3 months, putting 2 hours aside every single night, just typing up this 100-page document. But it turns out he actually did it through the university in the end. So the university said, we'll do it under our umbrella, basically. We have an ethics policy. We have all of that sorted out. We will get it done. And you can see poor Rosie's tumours, left to right. This was over 2 months. The tumours started to drop away. The striking thing about this is the idea of citizen science, where a punter in the streets with a computer science background can use their skills in the scientific process, Professor Thomas says. That's a very impressive thing. Very cool. And again, I talked about this on socials the other day, and people were like, oh, it's just a dog. He just saved one dog. That is not the point. You need to pay attention. This is the dawning of personalized medicine, the ability to synthesize an RNA and a vaccine for an individual person based on their individual genome cost effectively. Very exciting, thanks to AI. So when people were like, oh, AI is just going to destroy the world and it's terrible technology, you have to point them towards this kind of information, because he used ChatGPT to help him work out what the process was. He used it as an assistant to guide him through how to make a personalized cancer vaccine. They used AlphaFold. AlphaFold is based on generative artificial intelligence. This would not have been possible, nor what the implications of this are, which are being able to cure cancers individually in humans, probably in the next few years. This is mind-blowing news.